what we are going to do is, we are going to discuss algebra exam model questions. Algebra exam model questions solved in ANIL NAIR's way. Now what we will do is, what are the things that we are going to discuss? First, we are going to solve how to solve higher order equations. How to solve higher order equations when variable is given a value. When variable is given a value, how to solve higher order equations without substitution. This is the method. Without substitution, how to solve higher order equations when a variable is associated with a value, and that too without substitution. Next concept which we are going to use, how to use digital sum in algebra problems. How to use digital sum in algebra problems. How to use digital sum in algebra problems. Third concept is when to use which method. When to use which method. When to use which method. Any interested students, if you want the class PDF, if you want the class PDF with questions, you can WhatsApp this number 8050067891. Right? I'll be very happy to give the questions PDF to you. Answers you have to attend the class. Right? Now, one by one we will discuss these three important key points. Let us first get into concept number 1. Listen carefully, sir. You will solve some of the toughest questions in less than 20 seconds if you listen to the class with utmost attention. Concept number 1. Please write down. Concept number 1. First write down how to find digital sum for powers. How to find digital sum for powers, which I am going to use it in my problem. How to use digital sum for power. This is the first concept. Now see here. What do you mean by digital sum? Digital sum is nothing but sum of the digits until a single digit is obtained. Digital sum is nothing but sum of the digits until a single digit is obtained. Add the digits till you get a single digit, that is nothing but digital sum. Right? Digital sum until a single digit is obtained. So what are the various possible digital sum? 1, 2, 3, 4, 5, 6, 7, 8, 9. Even though single digit is 0, it is meaningless. Adding the digits and getting a single digit, adding the digits and getting a single digit 0, it is meaningless. Right? So these are all the possible digital sums that are possible. These are all the possible digital sums. These are all the possible digital sums. Now, if I call all these values as x, 1 cube divided by 9 is 1. Either you go for plus 1 or minus 1. Similarly, 2 cube divided by 9, which is 8 by 9 minus 1. 2 power 6 divided by 9, which is nothing but plus 1. Right? Now, if you observe here, 3 square, 3 power 2 is 9. 3 cube is 27. 2 plus 7, 9. Right? 6 square is 36. 36 digital sum is 9. 6 cube onwards, it is digital sum 9. 9 power, any natural number, it is 9. So 3, 6 and 9. Digital sum will be 9. Digital sum will be 9. For greater than or equivalent to 2 power. For greater than or equivalent to 2 power. 3 square is 9, 6 square is 36, 6 cube is 216, 9 square is 81, 9 cube is 729. So for 3, 6 and 9, digital sum will be 9 for greater than or equivalent to 2. 4 cube is 64, 64 divided by 9, which is nothing but 1. These over. Similarly, 7 cube is 343. 343 divided by 9. 3 plus 4, 7, 7 plus 3, 10, which is nothing but 1. 4 cube divided by 9 is 1. 7 cube divided by 9 is 1. 5 cube is 125. 125 digital sum is 8. 8 divided by 9, which is nothing but minus 1. Which is nothing but minus 1. Listen carefully, sir. If you miss out this one, if you miss this one, right? If you miss this one, then the problems will be little tough for you. Just 1 minute. I'll create an empty slide for you. Right. Now see here. What is that we discussed? We discussed digital sum for 3, 6 and 9. Power greater than or equivalent to 2. Right? When divided by 9. Either 9 divided by 9 0 or you call it as 9. Next one, 4 cube divided by 9. 4 cube divided by 9 is nothing but 1. Next one, 5 cube divided by 9. 125 divided by 9, which is nothing but minus 1. 7 cube. 7 cube divided by 9. 343. 3 plus 4 plus 3, which is nothing but 1. I hope it is clear. 2 cube divided by 9. 8 divided by 9, which is nothing but minus 1, which is nothing but 1. 1 power any number when divided by 9 is 1. 1 over, 2 over, 3 over, 4, 5, 6, 7, 8. 8 divided by 9, which is nothing but minus 1. 8 divided by 9, which is nothing but minus 1. This is extremely important for us to solve some of the toughest algebra questions very, very fast. Now problems. Find the digital sum for. First question. 4 power 360. 4 power 360. Which power of 4 when divided by 9 I will getting plus 1 or minus 1. So it is 4 cube. 4 cube power 120. 4 cube is nothing but 64. 64 power 120. 64 digital sum is 6 plus 4 10. 1 power any number. Answer is nothing but 1. These why? Because I used 4 cube by 9 is 1. That helps me to solve this problem very, very fast. Suppose if it is 5 power 121 is there. I know that 5 cube by 9 is minus 1. So it is nothing but 5 cube power 40 into 5 power 1. 5 cube is 125. 125 sum is 8. 8 by 9 is minus 1. Minus 1 into 5 is minus 5. Positive remainder is nothing but 9 minus 5 4. 9 minus 5 4. Suppose if the question is 7 power 332 is there. 7 power 332 is there. This can be written as 7 cube power 110 into 7 square. 343 it is 1. 7 square is 49. 4 plus 9 13. 1 plus 3 4. 1 plus 3 4. I hope you are all there with me. Suppose if it is 1534 power 122 is there. 1534 power 122. I need to find the digital sum of these number. 153. Digital sum is, it is nothing but 9. It is removed. 4 power 122 is 4 power 3 power 40 into 4 square. This is nothing but 1. 16 digital sum is nothing but 7. Another one. 78 power 2123. 78 power 2123. Now see here. 78. 7 plus 8 15. 1 plus 5 6. 6 power any natural number greater than or equivalent to 2. This is nothing but power. Answer digital sum is nothing but 9. Answer digital sum it is nothing but 9. 12 power 168. 12 power 168. 12 digital sum is 3. 3 power any natural number greater than or equivalent to 2. Answer digital sum is nothing but 9. Answer digital sum it is nothing but 9. Next one. 7121 power 123. 7121 power 123. 7 plus 2 9 out. 1 plus 1 is 2. 2 power 3 power 41. 2 cube is 8. 8 by 9 minus 1. Minus 1 power odd minus 1. Positive remainder is nothing but 8. Positive remainder it is nothing but 8. I hope you have understood how to find out the digital sum for the powers. How to find out the digital sum for the powers. Why are we discussing digital sum in an algebra class? By knowing the digital sum concept, some of the toughest questions in algebra can be solved very, very easily. I hope the idea it is clear. Now, with this understanding, let us solve some good problems. Now, see the first question. First question, method number 1. I will solve this problem in multiple methods. You take any method that it is possible. Method number 1 is the traditional method. Method number 2 is ANIL NAIR's way of solving without answer options. Method number 3 is ANIL NAIR's way of solving with answer options. Method number 1. These are nothing but x power 4 minus 17x cube plus 17x square minus 17x plus 17. If x equivalent to 16, find the value. X equivalent to 16, that means x plus 1 is nothing but 17. X plus 1 it is nothing but 17. Wherever 17 is there, substitute x plus 1 into x cube. Wherever 17 is there, substitute x plus 1 into x square. Wherever 17 is there, substitute x plus 1 into x plus 17. These are nothing but x power 4 minus x power 4 minus x cube plus x cube plus x square minus x square minus x plus 17 minus x plus 17 plus minus plus minus plus minus plus minus cancelled. So what is remaining? 17 minus x it is remaining. 17 minus x. 17 minus 16. Answer for this question is 1. Answer for this question is 1. I hope the idea it is clear. It is nothing but wherever 17 is there, substitute x plus 1. This is method number 1. Method number 2. Method number 2. Method number 2. Listen carefully, sir. This equation is x power 4 minus 17x cube plus 17x square minus 17x plus 17. What is the final value that we got? 17 minus x. 17 minus x. I got 17 minus x. 17 is as it is. Minus 17x became 17. So, in these kind of problems, take the last two terms. I will tell you why we are taking the last two terms. If we take the last two terms, minus 17x plus 17. This method 2 is derived from method number 1. Method 2 is derived from method number 1. Through observation, this concept is derived. Minus 17x plus 17. We got 17 minus x. This is x equivalent to 16. To get minus x, what I need to add? Plus 16. These are nothing but 17 minus x. That means in these kind of questions, only focus on the last two terms. Last two terms are 17 minus 17x. If this is minus, add the value which is equated with x. It is nothing but plus 16x. 17 minus x we got. Why are we adding plus 16x? Because in method number 1 I got 17 minus x. Minus 17x has to become minus x. So plus 16x needs to be added. From where we got these 16x? 16 is the value that is given. You only focus on the last two terms. Go to the second term. If it is a negative, add the value. If it is a positive, subtract the value, which is 17 minus x. This is one way to solve. I hope it is clear, right? This is a traditional method where 17 is equated with x plus 1. I got the answer 17 minus x. Method 2 is derived from method 1. I need to get 17 minus x. So from 2 minus 17x, what needs to be added? Which is plus 16x. Now see here. This is method number 2. Now let us see method number 3. Method number 3. Method number 3 is nothing but using digital sum. Method number 3 is nothing but using digital sum. How to use a digital sum? This actual value is nothing but 16 power 4 minus 17 into 16 power 3. These are nothing but 17 into 16 square minus 17 into 16 plus 17. This is the actual value when a variable is replaced with value 16 power 1. Now if you see here, 16 is nothing but 7. 7 power 4. 17 is 8. These nothing but 7 cube. 17 is 8. 1 plus 6 is 7. 7 square is 49. 17 it is 8. 16 digital sum is 7. And 17 digital sum is 8. 7 power 4 is 343 into 7. 7 cube into 7. These 1. These nothing but 7. 7 cube digital sum is 1. 8 into 49 digital sum is 4. Minus 8 into 7 plus 8. Now see here. These nothing but 7 minus 8. 8 4s are 32, which is 5. 8 7s are 56. 5 plus 6 11. 1 plus 1 2. And it is plus 8. 8 minus 8 it is cancelled. 7 plus 5 12. 12 minus 2 10. 10 digital sum is nothing but 1. 10 digital sum is nothing but 1. Which answer option has got digital sum 1? I hope it is clear. I hope it is clear. Method number 3, I hope it is clear. 16 power 4. The coefficients can be any values, right? The wantedly I created such values. Once we start solving problems, it will be extremely easy. 16 is 7 power 4. 16 is 7 cube. 16 is 7 square. 8 into 7 plus 8. 7 minus 8 plus 8 into 4 minus 8 into 7 plus 8. Answer is nothing but 1. When answer options are there, keep an eye on the answer options. The more and more problems we solve, we will know which method to be used when. Actually, just by looking at a question itself, you can say that the answer is 1 by and another method that also we will discuss. Method number 3, using digital sum. I hope it is clear. Method number 2, only focusing on the last 2 terms. Method number 1, replacing 17 with 16 plus 1. There is also another method, method number 4. Right? You don't need to worry about the concepts. Method number 4. Method number 4 is nothing but it uses the concept of complete equation. It uses the concept of complete equation. What is this concept of complete equation? Now, if you see here, the degree of these expression, it can be either even or odd. The degree of the expression, it is either even or odd. In this case, it is an even number. Next one, right? Degree is decreasing by 1 unit. Degree is decreasing by 1 unit. X power 4 is becoming x cube, x square, x, and it is x power 0. I hope it is clear. There is a plus and minus sign change that is happening. Now see here. In this case, if the degree is even, directly the answer is 1. If the degree is odd, and directly the answer is minus 1. Under one condition, if the value given is k and the coefficient values are k plus 1 and the coefficient values are k plus 1, 16 and k plus 1. This is taken from an higher algebra Hall and Knight book. Little complex to understand, so we'll go with method 1, 2 and 3. If it is 16, coefficients are k plus 1, directly the answer is 1. You please forget these method number 4 for some point of time. These little complex to understand. Go by method 2 or probably by using method number 3. Right? Now see here. Listen carefully. Listen carefully. X equivalent to 11. 11 x power 5 minus 12x power 4 plus 12x cube minus 12x square plus 12x plus 1. Method number 1. Wherever 12 is there, substitute x plus 1. That is the idea. Method number 2, which is a condensed version of method number 1. Take the last 2 terms. Last 2 terms are 12x minus 1. If it is plus, put minus. What is the value of x that is associated? Minus 11x. So, these is nothing but x minus 1. X minus 1 is nothing but 11 minus 1. Answer is nothing but 10. Answer is nothing but 10. I hope method number 2, it is clear. Method number 2, it is clear. Method number 3. Method number 3. It is 11. 11 is 2. By using a digital sum concept. By using a digital sum concept. Now see here. These 11 is nothing but 2. 2 power 5 is 32. 3 plus 2, 5. 1 plus 2 is 3. 3 into any number 3. 3 into any number 3. 3 into any number 3. Right? These is nothing but 5 minus 1 plus 3k. 5 minus 1 plus 3k. These is nothing but 5 minus 1 is 4, which is 3k plus 4, which is 4 divided by 3, remainder 1. Answer when divided by 3, it should give a remainder 1. Answer when divided by 3, it should give a remainder 1. Answer is nothing but 10. I hope the idea it is clear. Unnecessarily you don't need to do digital sum. It's a time waster for you. 11 is 2. 2 power 5 is 32. 3 plus 2 is 5. 1 plus 2 it is 3. Again 1 plus 1 is 2. 2 power 4 is 16. 7. Plus 1 plus 2 is 3, 2 cube is 8, 1 plus 2 is 3, 2 square is 4, 1 plus 2 is 3, 1 plus 1 is nothing but 2 minus 1. This entire value is nothing but divisible by 3. Are you all with me? This entire value, it is nothing but divisible by 3. Divisible by 3. 5 minus 1 is 4. 4 when divided by 3, remainder 1. Answer when divided by 3, it should give a remainder 1. Answer when divided by 3, it should give a remainder 1. This is method number 3. Close to 25 problems if we solve, then you will get an idea how to do it very fast. Some other way of looking at the question. Method number 4. Depending upon your practice, you take any method. Divisible by 12, divisible by 12, divisible by 12. Finally, it is nothing but x power 5 minus 1. These is nothing but 11 power 5 minus 1 divided by 12. If I divide by 12, what is the remainder? Let us see. 11, 12 ones are 12, minus 1. Minus 1 power odd is minus 1. Minus 1, minus 1. So it is nothing but minus 2. That means the positive remainder should be 10. Therefore, the answer is also nothing but 10. I hope the idea it is clear. Sometimes just by looking at a question itself, you will get the idea. Divisible by 12, divisible by 12, divisible by 12. X when divided by 11. 12 when divided by 11, minus 1. Minus 1 power odd is minus 1. Minus 1 minus 1 is minus 2. Positive remainder is nothing but 10. These when divided by 12, positive remainder 10. Not possible. Not possible. A, B and D, it is not possible. Method number 5. I already told you, if the degree of that higher order equation is odd and the coefficients are in x plus 1, k plus 1 format, these 12x cube minus 12x square plus 12x, which is minus 12, which is minus 12. If you see here, these nothing but, right, x power 5 minus 12x plus 4, these nothing but minus 12. These nothing but plus 11. This is the question. This entire value, if the degree of the equation is 5 and the degree is decreasing by 1, coefficients are k plus 1. These nothing but minus 1. These entire value, it is nothing but minus 1. 11 minus 1, the answer is nothing but 10. I hope it is clear. Method 1, method 2, method 3, method 4 and method number 5. You can use any concept that comes into your mind. Depending upon the merit of the question, we will use a particular logic. Generally, method 2 will give you the answer very fast. Sometimes digital sum also will give you the answer very fast. I hope the idea it is clear. Now see here.